I'm sure that all of you have heard of global warming. When we combust fuel to power our cars and homes, we release CO2 into the atmosphere. This CO2 acts as a greenhouse gas, trapping heat from the sun in on Earth. The result is an increase in net temperature. As we have found, from the 1880s to the late 2000s, the temperature of the world has increased from negative 0.21 to 0.68 degrees Celsius, corresponding with the increase in parts per million in CO2, from 320 parts per million in 1955 to 398.29 parts per million in 2015. Global warming is a major problem that we need to deal with quickly. But it is not the only negative consequence of increase in CO2 levels in the atmosphere. This CO2 also contributes to ocean acidification, which not only has a damaging effect on marine ecosystems, but also affects all life on Earth. Not only does this increase in carbon dioxide negatively affect the atmosphere and increase temperature, as we will learn, some of the carbon dioxide is also absorbed into the ocean, negatively affecting the lives of organisms and the abundance of the substances they need to survive. However, before we can understand how this negatively affects organisms and how we must first learn the difference between acidic and alkaline substances, what a pH scale measures, why the ocean absorbs CO2, and finally, how the increase in carbon dioxide in the ocean leads to the increase of its acidity.
There are many definitions of acids and bases. The one that we are going to use is the Bronsted-Lowry definition. Bronsted-Lowry acid is anything that donates a proton or H plus cation in a reaction. Bronsted-Lowry base is anything that accepts a proton. This is because the atom bonded to a hydrogen atom can sometimes, with a little help, pull the electron away from the hydrogen atom, making a positive and a negative ion. This is more likely to happen if there are other negatively charged things, like the oxygen in water around the hydrogen to pull it away. This is why acid-base reactions often only happen in aqueous solutions. How acidic or basic a solution is measured using the pH scale. The higher the pH of a solution, the higher concentration of hydroxide anions, and the lower concentration of H plus cations. The opposite is true for low pH levels. Adding acids to a solution decreases the pH, and adding bases increases it. Pure water has a pH of 7, so that is the neutral pH. When you mix an acidic solution with an equally basic solution, they neutralize each other and the pH becomes 7. The pH scale is logarithmic, so when the pH decreases by 1 point, the concentration of H plus is actually multiplied by 10.
In order to understand how the acidification of water affects organisms, we must first understand why it is that the oceans absorb CO2 in the first place. According to Le Chatelier's principle, for a closed system, when one side of the balanced equation becomes different in color, concentration, pressure, and density, the other side of the equation will in turn change to maintain the balance of the reaction. In simpler terms, for a closed system, equilibrium is maintained no matter whether a reaction is forward or reverse. Therefore, for our purposes, when the Earth is a closed system, the increase of CO2 in the atmosphere results in the absorption of some of the CO2 into the ocean. This CO2 that is absorbed into the water is then combined with H2O to form carbonic acid, which in turn breaks down into bicarbonate and hydrogen ions. Because of Le Chatelier's principle, these hydrogen ions then bond with existing carbonate ions because of their opposite attraction. However, because this reaction takes place, there is considerably less carbonate ions in the surrounding water for aquatic organisms to use in their shells to protect them, as well as the fact that some hydrogen ions bond with the carbonate ions that make up the shells, destroying those systems. As we have seen, as more carbon dioxide is produced, the more acidic our oceans become, leading to the decrease of carbonate ions available for the formation of calcium carbonate, needed for the formation of the skeletons and shells of aquatic organisms. As these resources start to decrease, so will the populations of these lower chain organisms, resulting in the change of the species of aquatic animals that exist and impacting our lives as humans immensely.